Hello and welcome back to Sudoku Swami's pencil and paper method. Today, before we solve a puzzle from start to finish at the end of this video, we're going to talk about how we can utilize the implications of triplets and quads without actually filling them in. Remember, when we're doing puzzles with pencil and paper, our goal is to solve the puzzle by entering the fewest possible number of candidates so we don't destroy the paper with too many erasures and so the puzzle doesn't get too messy. Know what I mean? So let's go over to the puzzle board and take a look at how we can try to make the most of triples and quads whenever we see them. Alright, let's imagine we're doing a puzzle and we come across a situation like we see here in block 4, where we have 6 digits already filled in, leaving exactly 3 empty cells in either a row or a column, here being row 4. So we have 3, 6, 9, 8, 1, 4 already filled in, which means these 3 cells must contain the candidates 2, 5, and 7 in some order that is unknown to us at this moment. Those 3 colored cells contain a triple of 2, 5, and 7. We know that those 3 candidates must eventually go into those 3 cells, even though we don't yet know which is which. Now, according to our rules, we're not going to fill them in until we have more information. So let's leave them blank for now, even though we need to make a mental note of what they are and be sure to remember them. Now, since 2, 5, and 7 must go into these 3 cells, we know that the other 6 cells in row 4 must contain these exact same digits that are already placed in block 4, right? These 6 cells must contain 3, 6, 9, 8, 1, 4 in order to complete row 4 with all 9 digits. So at worst, these 6 cells are a sixer, or a subset of 6. But chances are it's not going to be a perfect sixer, and it will probably be some combination of other subsets depending on what other digits are placed elsewhere in the puzzle. Like it could be a quint and a single, and this could be a hidden single. Or it could be a quad and a pair, and either one could be hidden. Like it could be a hidden quad and a naked pair, or it could be a naked quad and a hidden pair. Or it could be 2 naked triples, or a naked triple and a hidden triple. Or it could be 3 naked pairs. The possibilities are endless. But no matter what, 3, 6, 9, 8, 1, 4 must go into those 6 cells one way or the other. And they can appear in any number of ways. But let's say 2 of those digits are already filled in. Like let's say this cell is a 9 and this cell is a 4. Now we know that these 4 remaining cells are a quad, a subset of 4. They must contain 1, 3, 6, and 8 in some order that we don't know yet. But now let's say we have a 1 here in block 6. This means that these 3 cells can no longer contain a 1. Which further means that our quad has been reduced to a triple and a single. These 3 cells in the blue rectangle can only contain 3, 6, and 8 now, which means they are a triple. And so this last remaining cell in row 4 must be a hidden or a naked single, and we can fill it in just like that. And we would continue solving the puzzle remembering that we have 2 triples in row 4 now, 2, 5, 7 in block 4, and 3, 6, 8 in block 6. Okay, so now let's go back. Let's say this cell is a 9 again, and this cell is the 4. So again, these 4 remaining cells are a quad of some sort, containing 1, 3, 6, and 8. But now let's say that we have a 6 here and an 8 here. Now our quad has been reduced to 2 naked pairs. These 2 cells can no longer contain a 6 or an 8, which means they can only contain 1 and 3. And we can fill them in as a naked pair, which leaves only 2 cells left in row 4 that are unaccounted for, and so they must be a naked pair of 8 and 6, right? And we know all these things because of the implications of our first triple over here of 2, 5, 7 at the top of block 4, and the resulting quad in row 4 without even filling them in. Capiche? Now notice that if the extra 8 and the extra 6 were in 2 different blocks like this, these 4 cells would still be a quad. In order to turn the quad into 2 naked pairs, the 6 and the 8 must be in the same block, like this. And don't forget, the first 6 numbers here in block 4 don't always have to be solved. For instance, you could have a naked pair in there, like this, but it would still mean that those same 6 digits are still accounted for in block 4, so that would not affect our triple of 2, 5, and 7. Does everybody get that? And of course, this will work just the same in a vertical chute, so let's take a quick look at that before we solve our puzzle. Okay, here in block 2, we've got 5, 6, 1, 8, 2, 7. And because of the way they're arranged, we know that in column 5 and in block 2, we've got a triple of 3, 4, and 9 because they're the only 3 digits that are left to complete that block. Okay? But we're not going to fill them in, so let's delete them and remember what they are. So that means these 6 cells must contain 5, 6, 1, 8, 2, 7, right? But now let's say we have an 8 in this cell and a 1 in this cell. So that turns these 4 cells into a quad. They have to be 2, 5, 6, and 7 in some order. So now if there's a 2 in this cell, that turns these 3 cells into a triple of 5, 6, and 7, which means this cell must be a naked or a hidden single on 2, and we can fill it in just like that. So now let's go back. Let's say we have a 1 here and an 8 here. So now that means these 4 cells are a quad again of 2, 5, 6, and 7. But now if we have a 2 here and a 5 here, this becomes 2 naked pairs. Now these 2 cells can only be 7 and 6, and these 2 cells can only be 2 and 5. Got it? All right, let's solve today's puzzle. Now this puzzle was sent to me by one of my subscribers named Frank, who lives in Chicago. He asked me not to mention his surname, so we'll just call him Chicago Frank. They actually have some really good Franks in Chicago, if you know what I mean. Ha ha. Anyway, Chicago Frank said he found it in a puzzle book and could not solve it and asked if I could give him some advice about it. And then when I went through it, I realized that it contains a few examples of what we were just talking about earlier, so I decided to use this puzzle for today's lesson. Okay, we've got 26 givens. Now, if we were looking at full-on automated candidate lists, this puzzle could be easily solved in about 2 minutes using the techniques I teach in my complete course. No exaggeration. However, as a pencil and paper puzzle, it's going to be a little bit trickier than that. If you recall from lesson number 6 in this series, the plan is that we're only going to enter singles, conjugate pairs, naked pairs, and 2 by 2 by 2 triples. Now these are only my suggested rules, so you don't have to do it exactly the way that I am recommending. You can, of course, do it however you want. Whatever works for you is always the best strategy. I'm just trying to give you some guidelines to work from, okay? All right, here we go. Let's start by going through the numbers in sequence and enter as many conjugate pairs and singles as we can, and then we'll take it from there, okay? Now don't worry, if I miss something, we'll pick it up eventually. If I solved this puzzle 10 times, I'd probably do it 10 different ways regarding the order of which things I happen to see first. So let's start with the ones. We've got a 1 here and a 1 here, so that means one of these cells must be a 1. That is a conjugate pair. Now I don't see anything on the 2s, so let's move to the 3s, and we've got a 3 here and a 3 here. So that means one of these cells must be a 3. And now that this 3 rules column 7 and these 3s rule column 9, that means one of these cells must be a 3. That's another conjugate pair. Okay, let's move to the 4s. Now because of this 4 and this 4, we can enter a 4 in that cell. Okay? And now, because of these 2 4s down here, we know that one of these cells must be a 4. That's another conjugate pair. And I think that's it for the 4s. So let's move to the 5s. And we've got something called a foursome on the 5s. These 4 5s interact with block 5 in such a way that this cell must be solved for 5 because that's the only place left in that block for a 5 to go. So we can enter that, and there's nothing else on the 5, so let's move to the 6s. We've got a 6 in row 7, a 6 in row 8, and this 6 in column 3 means that one of these two cells must be a 6, and we can enter a conjugate pair in there. And now because of this 6 in column 6 and this one in row 6, we know that a 6 must go into one of these two cells. And because these two 6s now rule column 4 and this one rules column 6, a 6 must go into one of those two cells. All right, and that's it for the 6s, so let's move to the 7s. And because of this 7 and this 7, we know we can enter a 7 into that cell. So let's do that. And then because of this 7 and this 7, we know we can enter a 7 into that cell. And I believe that's it for the 7, so let's move to the 8s. Because of this 8 in column 2 and this one in column 3, we know one of these cells must be an 8. And because of this 8 up here in row 1, we know that this must be an 8 because that's the only cell left in row 3 that can contain an 8. So let's enter that. And now because of this 8 in column 8, and this one in column 7, and this one down here in row 7, we know that an 8 must go into one of these two cells. Okay, so let's move to the 9s. And now because of this 9 all by itself in row 5, we know one of these cells must contain a 9 because these three cells up here are blocked. And now because these 9s rule row 6, and this one rules row 5, one of these cells must be a 9. Okay? Now notice in row 4, we've got 4 empty cells, right? So they must be a quad of some sort. They must contain 2, 4, 6, and 9 in some order. But we've got a 2 and a 9 in block 6, so these two cells cannot be 2 and 9. They can only be a naked pair of 4 and 6, and we can enter it just like that. Now that means this cell cannot be a 6, so we can eliminate that. And these two cells must be 2 and 9 because they're the only two digits left in row 4. So we've got a 2 up here, so this can't be a 2. This has to be the 9. So you can erase this 9 and enter a 2 here. And this 6 was part of a conjugate pair, so that must be the solution to that cell. So we can enter those 3 numbers. And now we have another naked pair in block 6. These two cells must be 1 and 3 because they're the only two numbers left unaccounted for in that block. So let's get rid of those colors. Now let's look at column 7. You know, when you're solving puzzles, in general, you should always gravitate toward the houses that have the fewest number of empty cells because that's going to be the path of least resistance. So we have a triple here in column 7 because there are only 3 cells left, and they must be 1, 4, and 9 because those are the missing digits in that column. But we've got a 4 and a 9 here, so this has to be a 1. And we've got a 4 here, so this has to be a 9, and then this cell has to be a 4. So we can enter those. And let's get rid of those colors. And now we've got a couple more conjugate pairs on 2. Because of this 2 in column 4 and this 2 in column 6, one of these cells must contain a 2. And because of this 2 in row 4 and this 2 in row 6, one of these two cells must contain a 2. Those are both conjugate pairs. All right, now let's take a look at column 5. Again, we've got 4 unsolved cells, so that's a quad of some kind. They must contain 1, 2, 6, and 9. But because in row 8, we've got a 9, a 6, and a 1, this has to be the 2. So this cannot be a 2, okay? So we can enter that 2. Let's mark that with this color. That's going to be a 2. So now we've got a triple remaining in these last 3 cells, and they must be 1, 6, and 9. But we've got a 1 over here and a 6 over here, so this cell has to be the 9. All right? And that leaves a naked pair of 1 and 6 for these two cells. And now we can enter these. All right, so let's get rid of those colors. And now, because of this new 4 up in row 1, and this 4 in row 3, and this 4 in column 5, we can crosshatch a 4 into this cell. So let's put that in. And now because of that new 4, and this one down here in column, well, we don't need it. These 3 cells are blocked. So we can crosshatch a 4 into this cell. That must also be a 4. Okay? So now if we look at block 5, there are only 2 cells left remaining to be solved, and they must be 1 and 8. Okay? So we can enter that. Now we've got a new 9 down here and a 9 here. So that means this cell has to be a 9, and we can enter that, which leaves another naked pair of 3 and 7 in these 2 cells because they are the last 2 cells unaccounted for in column 6. Okay? Then we have 2 cells unaccounted for in block 2, and they must also be 3 and 7, but because of this 7 over here, this cannot be a 7. This has to be the 3, and this has to be the 7. So we can go ahead and enter those. Let's get rid of the colors again. Now here's something interesting going on the right side of the puzzle. We've got a naked pair of 1 and 3 in column 9, right? So there can be no other 1s in that column. And then these 3 cells are blocked, so this has to be a conjugate pair on 1. So that makes these 4 cells an X-wing. And we know that one diagonal pair of those must be true and the other must be false, but we don't know which is which. But that means there can be no other 1s in row 1, and there can be no other 1s in row 2. So this cannot be a 1, and since that's a naked pair, this can't be a 6, so we can go ahead and enter those 2 numbers. All right? Now in column 4, we have a naked pair in these last 2 cells down here in row 8 and row 9, and they have to be 1 and 8, but there's a 1 here, so this has to be the 8, and this has to be the 1, but there's an 8 over here, so we can erase that 8, and this is a conjugate pair, so we can enter this 8, and this 1. So let's enter those. And now, because of this new 2 in row 8 and this original 2 in column 8, we can crosshatch a 2 into this cell. This must be a 2. So we're going to start using a different color to mark cells that are definitely singles. Let's see, let's use this color here. So that is going to be a 2, okay? But that was a conjugate pair on 4, so this cell must be a 4. It cannot be a 3, which means this cell must be a 3, okay? Which means this cannot be a 3, so you can erase that 3. This must be a 7, and we can erase this 7 because that can't be a 7, and because that was a naked pair, that has to be a 3. But now since this cell has to be a 4, this one up here cannot be a 4, and that's a naked pair, so this cannot be a 6, and you can erase that 6, and now we can enter all of those numbers. Okay? All right, so let's get rid of those colors. And now we've only got 2 cells left in row 8, so they must be 3 and 5. And because of this naked pair of 1 and 3, this one cannot be a 3. It has to be a 5, and this has to be a 3. Got it? And now we've got a full house in row 7. This cell can only be a 7 because that's the only number left for that house. And now we've got a naked pair up here in column 9 and in block 3, and it has to be 6 and 9, but there's a 9 here and a 6 here. Let me mark those. There's a 9 here and a 6 here, so this has to be the 9, and this has to be the 6, and we can enter those, leaving a naked pair of 1 and 5 in these 2 cells. And now in row 3, we have a naked pair of 6 and 9 because those are the only 2 numbers left to complete that row. Okay? Now in row 9, we've only got 3 cells left, so that's a triple, and they must be 2, 5, and 6. But we've got a 5 and a 6 here, so this cell must be a 2. So let's mark that with the other color. So that's a 2, and this must be 5 and 6 and a 5 and 6 naked pair, right? So now if this cell is a 2, this cannot be a 2. And since this was a conjugate pair, this cell has to be a 2 and it can't be an 8. So you can erase that 8. This was a conjugate pair, so this cell must be an 8 and it cannot be a 9. So we erase that 9, and this cell has to be a 9 because that was a conjugate pair, okay? So if this is an 8, this cell is not an 8, and you can erase that 8, it must be a 1. If this is a 1, this can't be a 1, you can erase that 1, and this must be an 8. Now, if this is a 1, this cell cannot be a 1. You can erase that. That must be a 3. If this is a 3, that's not a 3, and it must be a 1. Now, if this cell is a 9, this cell cannot be a 9. It must be a 6. So this cell cannot be a 6 and must be a 9. And then because this cell is a 6, this cannot be a 6. That must be a 5. And because that's a 5, you can erase that 5, and this must be a 6. And we can go ahead and enter all of those numbers. Okay, so let's get rid of those colors. We're almost done. We've got a full house in block 4, so that must be a 3. And now these two cells up here are a naked pair of 1 and 7 because they're the only two numbers left. But because of this 7, this has to be the 1, and this has to be the 7. So if this is a 1, this can't be a 1, and it must be a 5. And if this is a 5, you can erase that 5 and enter that 1. So let's enter those. Sorry about being inconsistent with the colors, but you get the idea. All right, so now we've got a full house in row 2. That's got to be a 5. And now we've got a full house in column 2. That's got to be a 2. And then the last cell is row 1, column 1, and that can only be a 3, and the puzzle is done. So there you go, Chicago Frank. Okay, that's going to do it for today. If you enjoyed this video, please click the red subscribe button, the thumbs up icon, and be sure to click the little bell icon if you would like to be notified of new video uploads. And don't forget, if anyone has a puzzle from a newspaper, a magazine, a puzzle book, or whatever that you would like to see me solve in a future video, please send it to me at sudokuswami@gmail.com, okay? In the next lesson, before we solve our puzzle, we're going to talk about something really cool and really important that most people overlook or ignore. It's a commonly occurring but very powerful technique, and I'm sure you won't want to miss it. And then for a change, we're going to solve a puzzle from start to finish without filling in a single candidate. So I hope you will join me for all of that. In the meantime, be well and be happy.